Okay, in the last video I talked about the vertical line test and how it can show that some functions aren't really functions. But there is a way to write a function as a function even though it may not look like a function. And these are called piecewise defined functions. They're defined in pieces. So let me give you an example. This, if you're following in the Stewart's calculus book, this is example 7 in section 1.1. A function f is defined by f of x is equal to, okay, 1 minus x. Oops. If x is less than or equal to negative 1. So if x is less than or equal to negative 1. And x squared if x is greater than negative 1. Okay, so the example asks us to evaluate f of negative 2, f of negative 1, and f of 0. And before I begin evaluating those, I want to just say if you piecewise defined functions are defined in pieces. Okay, so in this case for f of x, the graph of f of x will look like 1 minus x beyond and equal to negative 1. Well, less than and equal to negative 1. And it'll look like x squared beyond negative 1. So if you graph this, which I will show you in a second, it'll look kind of funny. It might be, so here's like negative 1 and it's x squared greater than negative 1, so it's probably like that. And then 1 minus x, so 1 minus x, maybe something like that. There's a jump in it. At least that's what I think right now. So let's evaluate this. Okay, f of negative 2. Well, negative 2 is less than or equal to negative 1, so we're going to use this case of f of x. So we plug in negative 2. And that's just 1 plus 2. Right? So 1 plus 2 is 3. Okie dokie. We're good so far. F of negative 1. Negative 1 is equal to negative 1 here, so we're going to use the top case again. So 1 minus negative 1. And minus minus is just a plus plus. So 1 plus 1 is 2. And then for this next case, it's f of 0, which is greater than negative 1. So we're going to use the bottom case. And to make room, I just slid this up. So the bottom case is 0 squared. And 0 to the power of anything is 0. So that is how you evaluate piecewise defined functions. They are defined in pieces, and based on what you're evaluating at what x, you choose a part of the piecewise defined function. I also think, no, composite function is something else. This is piecewise defined function. So now I'm gonna open up my grapher program in utilities, and that comes standard with all Macs. And I have a Mac, so we're gonna open it up. I'm gonna fit it to your viewing screen. So if you go here to piecewise, 2 conditions, and what did we say this was? We said 1 minus x if x is less than or equal to negative 1, and then we said x squared for x greater than negative 1. And oh, okay, I was wrong in my initial graphing. So if we zoom in and move up, this is what it looks like. You have here at negative 1, to the right, you have x squared, the graph of x squared, and to the left of negative 1, you have, and at negative 1, you have the values for negative x plus 1 or 1 minus x, which is a graph like this with a negative slope, and it should have the intercept of 1. But that's what piecewise defined graphs or functions look like graphically or graphic-wise. So that's piecewise defined functions. And next we'll go into, maybe we'll explore the absolute value function and how to make that a piecewise defined function. So see you guys later.